Rahul Khadke, ask Rahul Khadke to rejoin. Okay. Okay. So we will start with this particular again slide where we will discuss about what we are going to discuss in this particular chapter. Uh, so this is a syllabus: engine fuel system requirements, mixture requirements, simple carburetor, additional system in a modern carburetor, compensating devices, and calculation of air fuel ratio, calculation of main dimensions of air fuel supply, and petrol injection system. This is the syllabus part what we are supposed to discuss. And I think engine fuel requirements we have discussed, mixture requirements to some extent, to some amount we have discussed, but after discussing engine fuel requirements, we went on to simple carburetor, and we will be discussing mixture requirements in detail. So moving ahead, now let us start with okay. Uh, today what we are going to discuss is about the construction and working of a simple carburetor as a part of the points whatever we have earlier discussed and the remaining part. So basically, we will start with what is the need of a carburetor. So basically, what is the need? The need is that the engine which we are going to use this particular carburetor is a such an engine that we will be how to prepare air fuel mixture outside the engine. Correct. So we are supposed to here prepare the mixture outside the engine, and therefore to still some are joining. Okay. Um, so in order to understand the carburetor, first we should understand what is combustion. So that will help better in understanding what a carburetor is. So what is combustion basically? So as we have discussed earlier, the combustion is a process of burning the hydrocarbon fuel, and this burning process is an oxidation process, and the products what we are going to get is carbon dioxide and water, and in this particular process it is going to liberate some amount of heat. Therefore, when we are talking about liberating heat, which it becomes combustion. Okay, so that is our aim. So this is our aim, and in order to produce this particular heat, this is what we require, and in order to this we are burning the fuel, and the burning process is what we call as oxidation over here. And the oxidation, in order to happen the oxidation, we have to supply the air. So that is how it becomes the hydrocarbon from the fuel is combining with oxygen in the air to produce carbon dioxide as a byproduct and water. So this is the theoretical combustion process when we consider that all the hydrocarbon in the fuel is being burned. Okay, so this is what we are expecting to happen. So basically it is like this. So chemically written, this is the hydrocarbon, and we have here the oxygen. When combined, we get carbon dioxide and water. So C gets converted to CO2 and H gets converted to H2. And this particular process is endothermic, exothermic in nature, and therefore it liberates heat. So this is a combustion process. And what we are trying to understand is why a carburetor is required. Now here comes uh, the point why carburetor is required. So it means that we require to mix fuel with air, and this has to be done outside the engine according to the principle of SI engine, because we are introducing mixture. We are supposed to introduce the air fuel mixture into the engine. That means if we are supposed to introduce air fuel mixture, then we have to prepare it before it is being supplied, and that is where the requirement of carburetor is coming into picture. Okay. Now, what is the mixture requirement? The mixture requirement is that it should be a homogeneous mixture of air and fuel. Okay. What is the meaning of homogeneous? Uh, Here, when we are saying it is homogeneous, we mean to say that if you take a sample from any corner of the mixture in a container, if it is placed, then that will have same amount of hydrocarbon molecules and of oxygen molecules or air molecules. So everywhere the number of molecules of hydrocarbon and number of molecules of oxygen, if you take the sample from any corner of the vessel, it will be same. That is what you call by homogeneity. Okay, so we want a homogeneous mixture of air and fuel vapor. So here I have written very clearly, we are talking of not the fuel but fuel vapor. So fuel vapor and air, we have to ensure that the mixture has to be homogeneous. This homogeneity is very important in case of SI engine. And then what we are doing, we are using a spark plug to ignite this particular mixture. We are using a spark plug. So first we are introducing the mixture into the engine, which is homogeneous in nature. And what the mixture constitutes of? It consists of air and fuel vapor. So the mixture of air and fuel vapor, which is homogeneous, is introduced into the engine. And then we are using a spark plug to ignite it. Okay. And if this is to happen, then what is the problem? What is the problem? What we are going to? What is the difficulty? What we are having? Now here we are talking of mixing fuel and air. So the problem is air is gaseous and fuel is in the vapor liquid state. Okay, so if you take air as it is, then it is in the gaseous state. If you take the fuel as it is in the liquid state. So we cannot mix a gas and a liquid. So that is the difficulty what we are arising, what we are having. Okay, so we have to ensure that somehow the air which is gaseous and the fuel which is in liquid state has to be mixed properly. Okay, so that is where our next problem coming. Therefore, the mixing them is a problem. Being one in gaseous, another is in liquid, and that is the problem. Mixing this two is a problem because we cannot mix a gas in a liquid. Okay, that becomes an issue. So then what is the solution? So somehow we have to find out a solution. So what is the solution? Either here we have to convert the liquid into vapor. That is the solution. So liquid is the fuel liquid is being converted into vapor, and once it is in the vapor state, then it can be mixed with air which is in the gaseous state. So now we have two gases. One is the fuel vapor and another is the air. And this particular two gaseous things can be mixed now, and then mix the fuel vapor with air. Okay, so this is the solution what we have, and therefore a proper device is required which has a provision of bringing in metered quantity of air. Therefore, this is where our requirement of carburetor is coming into picture. Okay, why it is coming into picture? Because we have to prepare the mixture outside, and the mixture has to be homogeneous. But the problem is, one is a gas, one is a liquid, and we want to mix this gas with liquid, which is not possible. Therefore, what we are finding out, we are trying to do, we are going to convert the liquid into initially gas, or that is vapor, and then that vapor has to be mixed, can be mixed with the gas, a gaseous air. So now air and the fuel vapor can be mixed, and that is where our requirement of a device coming into picture, which we call as a carburetor. Okay, so a proper device has to be there. And what is the function of that particular device? Bring in metered quantity of air, measured quantity of air. It has to ensure that it is going to measure some quantity, because we want to ensure that air fuel ratio has to be proper. And that is where we are saying we can bring some metered quantity of air into the system. Okay, so that is our first requirement of the this carburetor. Okay, so bring in metered quantity of air, then bring in metered quantity of fuel. So fuel has to be also metered before it is brought into the system. Okay, and the system what we have is what you call as a device, which you call as a carburetor. So before entering the air into the, allowing the air to enter into the carburetor, it has to be measured properly, fuel has to be measured properly, and then we are going to mix it. Now it is not that if you want to mix it, then as mentioned earlier, we have to convert into vapor, and in order to convert into vapor, we are going to atomize it. Okay, fuel is going to be atomized. Now this atomized fuel is then vaporized. Okay, and the vapor fuel is then mixed with air. Okay, so this liquid fuel, that is atomized fuel, is vaporized, and this fuel vapor is mixed with air to form air fuel mixture. So, and this mixture is what we are supposed to supply to the engine cylinder. Okay, and that is where our requirement of a carburetor is coming into picture. So why we require a carburetor? Why we require a carburetor? So all these things what we have discussed is made possible by what you call as a carburetor. What is made possible? We want to burn a fuel which is hydrocarbon, and to burning a fuel, oxygen is required. Oxygen is there in the air. That means we have to mix it with air. That means fuel has to be mixed with air. Correct? So and this particular mixture has to be homogeneous, and uh, this particular mixture, when introduced into the engine, is going to be burned by a spark. That is how the combustion is going to happen. And the difficulty in this process is that air is the gaseous form, and the fuel is in the liquid form. Therefore, we cannot mix them. And the solution what we have devised is convert the liquid into vapor and then mix it. But before doing so, we have to ensure that the quantity of air and quantity of fuel has to be metered properly, because we want to ensure proper air fuel ratio. So in order to ensure proper air fuel ratio, we have to meter the quantity of air, meter the quantity of fuel, then atomize the fuel, vaporize the fuel, and mix it with air. And then we can supply the air fuel mixture of required quality, that is air fuel ratio, into the engine. Okay, and the device which makes this possible is what we call as a carburetor. So here I expect that you have understood what a carburetor is. So basically, what is a carburetor? Carburetor is a device which makes the mixing of this particular air and fuel possible by ensuring proper amount of air and proper amount of fuel. Okay, so that is very important. Now moving ahead, now let us go for constructing, discussing the construction of a simple car. So that is where I think we have stopped in the previous lecture. Okay, so let us discuss or move ahead with the construction of a simple carburetor. So this is a simple carburetor. This is a simple carburetor. So you can see over here, we have what we call as a barrel. Okay, so let us discuss about initially the components. So a simple carburetor consists of what all things? One barrel. So what is the barrel here? So this particular pipe-like section, what you are seeing, that is what you call as a barrel. Okay. So this is your barrel, and this barrel helps in ensuring the air fuel mixture ratio is being going to be prepared and supplied to the engine. So on one side air is coming in, other side air fuel mixture is supplied to the engine. Okay, and here we are preparing the mixture. Here we are preparing the mixture. Now we have a main fuel jet. So this is your main fuel jet. Okay, what is its function? Its function is to supply the fuel into the barrel in the form of a jet. So we have in the previous class discussed why it's the form of a jet, because we have to atomize the fuel. Why we have to atomize the fuel? Because we want to increase the contact surface area of the fuel and the air. Why we have to increase the contact surface area of the fuel and of the air? Because we want to ensure that more heat is going to be absorbed. If you want to absorb more heat, why this heat is required? Because the fuel is supposed to be vaporized. Now, if this has to happen, then the required amount of heat has to be supplied to the fuel. Okay. So, in order to ensure that more heat is supposed to be supplied in the shortest time, what we did, we atomized the fuel into small droplets, and we now suspended the fuel droplets in the air. Now the contact surface area between the fuel and air has been increased. And what is the result? Now the fuel can absorb more heat. Now when the fuel absorbs more heat, it is now able to convert into vapor. Okay, so that is the function of main fuel jet. What is the function? To supply the fuel in the form of droplets of proper size, okay, into the barrel of the carburetor. Now next is the venturi. So here we have put a venturi. This is the venturi. As we discussed earlier, this is the venturi. Now what is the function of the venturi? So we have discussed earlier also that we want some mechanism to ensure that air is being brought into the system and fuel is also brought into the system. And venturi, whatever we have provided in the carburetor, is to ensure that the fuel is being brought into the system. Okay, so what happens when we provide the venturi? It ensures that the pressure difference is being created here, here, and here. If this venturi was not there, here it would have been atmospheric pressure, here it would have been also atmospheric pressure. And since both the sides of this particular pipe, here and here, it is atmospheric, nothing will come out. And if you want to come out here something, then we have to ensure that this region has to be lower pressure and here it has to be higher pressure. Okay. And therefore, what we have done here, you can clearly see it is vented to atmosphere. So since it is vented to atmosphere, that means here it is atmospheric pressure. Now here it is atmospheric pressure means if this pressure, atmospheric pressure, has to be higher, then here it has to be lower. So we have to provide here something which is making the pressure lower here in this region. And that is the function of the carburetor. Sorry, venturi of the carburetor. So what the venturi does? Venturi helps in sucking the fuel into the carburetor barrel. Okay, so that is the function of the venturi. Next is the throttle valve. So we have here a throttle valve. So here you can see this is what you call as a throttle valve. Now, as the name indicates, it is throttle. So what is throttling and all these things we will discuss later. Now the throttle valve is connected to which side? Connected to the engine side of the carburetor. Okay, that is when this is open. So this is connected to accelerator. So when we push the accelerator in case of a four-wheeler, accelerator pedal in a case of a four-wheeler, or turn the accelerator knob in case of a two-wheeler, then what is happening? This valve, throttle valve, is opening. And when we open this, more amount of air fuel mixture is being supplied to the engine. Okay, so that is what you call as a throttle valve. So what is a throttle valve? Throttle valve is a device or a valve which is ensuring the required amount of air fuel mixture to the engine. Okay, and for that it is connected to accelerator. So in a four-wheeler, it will be connected to accelerator pedal. So whenever we are pushing the accelerator pedal, if it is a two-wheeler, then it is connected to accelerator knob, which we turn, which is on the handle. So when we turn that particular accelerator knob, then what is happening? This particular valve is getting opened. So here, when it becomes vertical, it is open. When it is become horizontal, it is closed. So when we say when we are opening it, when it is making, we are trying to make it vertical from horizontal. So when we are moving it from horizontal to vertical, then more and more mixture will be supplied to the engine, and correspondingly more and more power will be produced, which is our requirement. So that is what you call as a throttle valve. Next is a choke. So this is your choke. Now where is the choke? Choke is connected to the air side of the engine, atmospheric side of the carburetor. So here choke is connected to the air side, and the throttle valve is connected to the mixture side of the carburetor. So this thing you will remember. So many times I have observed students making a mistake on regarding where this particular choke and throttle is being located. Okay, so they get confused regarding where to place it. So very clear instruction. The choke has to be on the air side, the inlet side of the carburetor. Now why it is on the inlet side and how it is working and all these things we are going to discuss later. Okay, so and what is its function, etc. So here we have a choke. Okay, so choke we are putting on the inlet side, throttle valve we are putting it on the outlet side of the carburetor. We have a float chamber. So this particular container is what you call as a float chamber. Okay, and in the float chamber we have the fuel. So in this particular float chamber we have the fuel. So always there will be some amount of fuel in the float chamber, and the level of this particular float chamber has to be always maintained properly. Now in a non-working condition, if the fuel level in this is this much, what will be the fuel level in the jet? It will be this much. So that is very important. Okay, that means if the fuel level is this much part of the fuel, it has to rise up before it comes out in the form of a jet. Okay, so that has to be always maintained. Now why it is done so? Because if this level was higher up to this, what will happen? From here the fuel will automatically start coming out. It will, even in the that is normal condition where the vehicle is not running, idle condition also, the fuel will start flowing over here. Okay, because we know the level has to be always same in a connected system. The level always remains same. So here if it is this much, then it will be this much over here. If it is higher, then it has to be higher. So this particular level is fixed. Okay, it is according to design, some amount of dip is being provided. Okay, so that is, and this particular chamber is what you call as a float chamber. Okay, so the float chamber is a reservoir for fuel. Okay, sometime you might have seen the people turning the vehicle when it is not starting and now. What actually they try to do? They try to turn the vehicle and thereby making the fuel from here to come out. Okay, or making this particular float move if it is getting stuck. Thereby some amount of the fuel over here will come here, etc., etc. Okay, so here there will be a fixed quantity of fuel always stored in this particular chamber, what we call as a float chamber. Remember, this is not a fuel tank. Okay, this is not the fuel tank. So fuel from the fuel tank is coming into this float chamber from here, and here you have a next is the float. So this is a float, which is a hollow vessel, airtight vessel, which is floating on the fuel, and to it connected is a valve. So here we have a needle valve, and this needle valve, when goes inside this, fuel flowing will stop. That means whenever the fuel level inside this comes down, this needle valve comes down, and therefore the fuel will come in. Okay, so that is how it is construction of that. So I hope the different parts of the simple carburetor everybody has understood. So basically it consists of a barrel, which is this pipe like section. Okay, this called as a barrel. uh, in this particular you have a main jet, which is the provision for coming in the fuel. This is the inlet side of the barrel. This is the outlet side of the barrel. In the inlet side, air is coming in. Here the fuel is coming in. Here the air fuel is mixed. That is, the mixture is being prepared, and here the mixture is being supplied to the engine. So this is the inlet side where air is coming in. This is the outlet side where the air fuel mixture is going into the engine cylinder. Okay, and here this is your venturi. So the venturi is provided to provide the required pressure differential for ensuring that fuel is going into come into the carburetor. Then we have a throttle valve. Throttle valve controls the quantity of the mixture flowing into the engine. Then we have a choke. Choke is on the inlet side. Then we have a float chamber. Float chamber is the reservoir for the fuel in the carburetor. Then we have a float. Float is placed in the float chamber, which floats on the fuel, which is the indicator of level. So when the level falls, it opens and allows more fuel. When the level reaches the required level, it closes the needle valve. That is, the needle valve goes in and stops the fuel coming in. So by providing this needle valve, sorry, the float works similar to the float in a water tank on the buildings. So everybody might have seen the float in the tank, over a tanks, water tanks, correct? So whenever the float levels, certain float reaches a certain level, then it has to be to give indication that it is filled. Okay, so similarly, when this level is falling down, this float will also come down, and accordingly the needle will come down and it will allow the fuel to come in. When this is moving up, the fuel, the needle will be going inside and it will be stopping the fuel coming into the float chamber. So that is about the different parts or the constructional details of a simple carburetor. Okay, so moving ahead now, let us discuss how a simple carburetor works. Before going ahead, uh, before going ahead, um, is there any problem? Which point which anybody has to uh, echo is there? Can somebody ensure echo is there? Shubham Gandule is saying no, echo is not there. But again, second one explanation. Which part is you want explanation? The constructional details, Shubham? Yes. Okay. The constructional detail explanation once again he wants. Okay. So we have here So in this slide, I have explained why a carburetor is required, what is the function of the carburetor in short. Okay. I hope this part is being understood by everybody. So here we discussed why mixture is required. Okay. How the mixture is, what is the difficulty here, what is the solution for that, and here we said we require a device. What is the function of the device? And we said that is how the carburetor is making possible to supply the required amount of air fuel mixture so that it can burn and liberate the heat, what is our aim. And in order to happen this, we require what we call as a carburetor.
सर कुठे गेले? सर कुठे गेले?
I think you can hear me now. Yes, I hope.
Yes, sir.
Yeah.
Yes, sir.
So the internet, college internet, went down. So there was a problem. So let us start once again. So uh, suddenly the so my screen is visible. Am I visible now?
No, sir.
No. Okay. I think now I am visible. Okay. The construction we are discussing. Here you can see the components. The barrel we said discussed. Then we discussed about the main fuel jet. The main fuel jet is through which the air fuel mixture, sorry, the fuel is going to come out into the barrel in order to prepare the mixture. Then we have the venturi. So this particular part is the venturi. हे नक्की कसं असणार आहे? हे पाईपचाच एक भाग असल्यासारखा आहे, एक जीव असल्यासारखं पाईपच्या, परंतु इथं पाईपचं डायमीटर कमी कमी होत गेलं आणि इथं पाईपचं डायमीटर वाढत वाढत गेलं. दॅट इज इट. म्हणजे इथलं पाईपचा जी वॉल आहे त्याची थिकनेस इथं वाढली. दॅट इज इट. कुठल्या साईडला वाढली? पाईपच्या आतल्या साईडला वाढली. Okay, so it is increasing on the inner side. That means here we have the diameter of the pipe to be decreasing from here to here, where we said it is a convergence section of the venturi, and we have then the divergence section. So then we discussed about the previous lecture itself that here mass flow rate of this and this we want to maintain constant. Okay. Then we have what we call as a throttle wall. So the throttle wall is this. Throttle wall ensures that a proper quantity of air fuel mixture is being supplied to the engine as per requirement, and for that it is connected to accelerator. So when we push the accelerator, it is expected that more air fuel mixture is going into the engine. Therefore, more power can be produced. We have a choke on the air side, that the inlet side of the barrel of the carburetor. Then we have the float chamber. So the temporary reservoir which is provided along with the carburetor is called as the float chamber, and the level in the float chamber, fuel level in the float chamber is always maintained fixed with the help of what you call as a float. So the float will with the needle ensures that the level is going to be always maintained. Whenever the level goes down, it allows the fuel to come in. Whenever the level moves up, it decreases the fuel, and whenever it reaches to the maximum level, whatever is expected, it closes the fuel coming in. Okay, so the fuel is coming in from the fuel tank. It will be coming into the float chamber. So that is about the float. So now somebody can give me the confirmation that you have understood the constructional details before going to working. Yes. Can anybody give me the confirmation that you understood? Okay. Saurabh,
Yes.
yes. Any doubt? Any doubt you are having?
Uh,
Please.
no, no, sir.
No doubt. Okay. So that means we can move ahead. So now knowing, understanding the different parts of a carburetor, let us move ahead to the working of a simple carburetor. How a simple carburetor is working. And this is a simple carburetor, like look like. So now what is there in the simple carburetor? What should be there? So there should be provision for sucking in the air. So some provision has to be made to suck the air, because we said that while discussing the carburetor initially, we said that metered quantity of the air has to brought into the carburetor. So to ensure that metered quantity of air is coming, there should be some mechanism, some provision for sucking the air. And as we discussed in the previous lecture, what is the provision for sucking? So what we have done, this particular side we are connecting to the engine cylinder, that is the inlet manifold. So this, when connected to inlet manifold, and when the piston in the engine cylinder goes down, there suction is being created. What is suction? Suction means negative pressure. Correct? Suction means negative pressure. That means since this is connected to the engine, on the engine side, inlet manifold, here also we will have a negative pressure. So here there will be a negative pressure, and here we have an atmospheric pressure, and that is the provision for sucking in the air. So whenever there is a pressure differential, we know that air starts flowing from this side to this side. That is higher pressure side to lower pressure side. Okay, so that is the provision for sucking in the air. So barrel is connected to one side to the engine, and the other side it is connected to atmospheric air, and that becomes the provision for sucking in the air. So that is first thing what we have to keep in mind. Second thing, provision for bringing in the fuel. So there should be some provision to bring in the fuel. And what is it? We have discussed over here, this main fuel jet. Okay, and how it is being done? A main fuel jet is opened in the venturi, in the venturi side of the carburetor, along with float chamber and float arrangement. So we have provided a main jet with a float chamber and a float in it. Okay, and the main jet is opening in the throat of the venturi. So we have discussed one convergence session and a throat, and then the divergence session. Okay, so the region where the diameter is minimum in the venturi is called as the throat. Okay, and in this particular region, in the throat region, we are making our main jet to open. Okay, so that is how we have made the provision for bringing the fuel. Now, what is happening due to this venturi? As we discussed, here we had a negative pressure. Okay, and this particular negative pressure and this particular positive pressure, there is a pressure differential being created, and due to the pressure difference, fuel is going to be injected into the carburetor barrel. So this is a provision for bringing in the fuel. Then there should be provision for preparing the air fuel mixture. And how it is done? Fuel is sprayed in the form of droplets. So when the fuel is sprayed in the form of droplets, air is coming from here. The fuel and the air droplets are going to come into contact with each other. There is a lot of surface area being provided between the fuel droplets here sprayed over here in this particular region, and the air coming from this side, and therefore the heat will be absorbed by the fuel droplets, and due to this particular heat, the fuel which is in the liquid form is being converted into vapor form. Okay, so we have you have heard the words like latent heat and sensible heat. Okay, so sensible heat is that which is going to increase the temperature. Okay, which will result in increase in the temperature, and the latent heat is that due to which the phase transformation is going to happen. Okay, so we have here latent heat. So that is what this latent heat is called as latent heat of vaporization. So the heat required for latent heat of vaporization by the fuel is absorbed from the air and thereby converting the liquid fuel into the heat absorbed for the phase change is what you call as latent heat. Okay, and if the vaporization is happening due to during that particular phase change process, then we call it as latent heat of vaporization. So the latent heat of vaporization is being heat is being sucked by the fuel from the air and thereby converting the liquid fuel into vapor. Okay, and for that what we have done, we have sprayed the fuel in the form of droplets. Why? We want to prepare the air fuel mixture of proper quality. So the droplets absorb the heat from the air. So when initially the fuel is being sprayed, they get dispersed into the air. Now the air and fuel contact has been established, and now the droplets has started absorbing the heat from the air, and they get converted into vapor. So the fuel droplets, which was in the liquid form, now are getting converted into fuel vapor, and then this particular fuel vapor and air is going to mix with each other to form air fuel vapor mixture of required proportion, of required quality. Okay, here we are using the word quality. So the quality of mixture means there should be proper amount of air and proper amount of fuel in it, and this mixture what has been prepared has to be supplied, and for that we have a throttle connected to accelerator. So throttle is opened and closed. So whenever we push um, the accelerator pedal or release the accelerator pedal, basically what we are doing, we are basically we are opening and closing the throttle valve. Okay, and why this opening and closing is being done? To control the quantity of the mixture which is being supplied to the engine. Okay, so and that is how we call SI engines are quantity governed. So very important point. Generally SI engines are called as quantity governed engines. Why we are calling it as quantity governed engines? Because we have used over here what we call as a throttle valve, and what the throttle valve is doing, it is going to control the mixture quantity being supplied to the engine. Quantity is being varied, changed when we push the accelerator. That means you press the accelerator more quantity of mixture is going into the engine. You press the accelerator less quantity of mixture is going into the engine. What it means? We are governing the engine by changing the quantity of the mixture, and therefore we call such engines as SI engines as quantity governed engines. So here we are saying SI engines are quantity governed. I hope everybody has understood what is quantity governing. So quantity governing means governing the engine. Now what is governing basically? I think in the BME you might have come across the word governing. So basically what happens is, suppose when the load on the engine increases or decreases, what we have to do? So something has to be there, isn't it? So when the load on the engine increases, something has to be there to tell the engine that the load has increased, and accordingly the engine has to respond to produce more power. When the load on the engine decreases, the engine has to produce less power, but for that engine has to come to understand. So then for that, what is being used? A device called as governor is used. That is, a governor is used to respond to the load, change in the load. Okay, so this particular system, what is the system over here? The system is the engine, and this engine system has to respond to the load on it. So in order to respond to the load, a device we are using which is going to help in responding the response of the system. So here the engine is going to respond to the load with the help of a device what we call as a governing. And process of this response system is what you call as governing. So basically you will be learning in detail about governor in subject theory of machine. Okay, there you will be learning in detail regarding how the governing is happening, what is the different type of governing, and so on. So many things you will be discussing over there. Okay, so here what we are trying to understand is what is governing, because we are using here the word governing, that is governed. So we say here the SI engines are quantity governed. Now, for that we should understand what is governing. So what is governing? Responding to the load, that is manipulating or ensuring the response of the system towards the load. So whenever the load increases or decreases, changes, accordingly the system has to respond, and that particular response is being done with the help of governor, and the process of the responsing of the system when the load changes is what we call as governing. सिंपल करून सांगतो, ज्या ज्या वेळेला इंजिन वरचा लोड चेंज होईल त्यावेळेला इंजिनला रिस्पॉन्ड करावं लागतं. मला भूक लागले, मला जेवायला पाहिजे, मला तहान लागले, पाणी प्यायला पाहिजे. That is my response. Correct? Similarly, when the load on engine is increasing, engine has to respond. How it is going to respond? By producing more power. But for that, engine has to understand first that load has increased. Somebody has to tell. And for that, we have provided one device. And the device is what you call as a governor. And the function of this particular responding to the load is what you call as a governing. Okay? And here the governing is being done with the help of quantity of the mixture, changing the quantity of the mixture. And therefore, we call it as quantity governed. So there may be a short note on the asked in the examination regarding quantity governing in the engines. Then you have to tell which governs are quantity governed, what do you mean by governing, what do you mean by quantity governing, and which engines are quantity governed and how they are governed, quantity governed. Okay, so all these points you have to cover in your answer. Okay, hope I am audible. Hope I am audible. Am I audible? Am I audible?
Yes, sir, you are.
Okay, okay, no problem. Is there any doubt regarding quantity governing? Let me know. Let me know. Can I know? Can I know? Is there a need of explaining once again the quantity governing? Somebody can, anybody having any doubt related to quantity governing can respond. Chalavine, Balaji Pise saying Chalavine governed. Chalavine nahi. Balaji, governing is responding to the load, change in the load. म्हणजे थोडक्यात काय आहे तर समजा मी आता एक थोडंसं ओझं घेऊन चालतोय आणि अचानक माझ्यावरती जी लोड आहे ती वाढला, तर मला पूर्वी जेवढी ताकद लावा लागत होती त्याच्यापेक्षा काहीतरी जास्त लावा लागेल, बरोबर? आणि ते मला ती माझी ताकद वाढवावं लागते. सो आय एम रिस्पॉन्डिंग टू द चेंज इन लोड. आणि त्याच्यासाठी मला कळायला पाहिजे managing the change in the load, managing the response for the change in the load. Correct? So that is what you by that is means that is where we said responding to the change in the load. So how we are going to respond? So this particular managing the change in the response when the load on the system changes. आता उदाहरणार्थ तुम्ही समजा एक पॉवर प्लांट घेतला, पॉवर प्लांट म्हणजे जिथे इलेक्ट्रिसिटी तयार होते. सो whenever suppose suddenly many houses using started using electricity in the different devices. Suddenly what happens? The load on the power plant increased. Now the power plant has to respond to it by increasing the some parameter related to supply, which is going to satisfy the load, higher load. Correct? Suppose suddenly everybody switched off the light. What happens? Suddenly the load on the power plant decreased. Then the power plant has to respond. How? By managing the change in the load. Okay. So this is in a similar manner. Engine also has to respond. म्हणजे आता समजा vehicle is going now on a plain road. Suddenly now it has started going uphill. What happened? Load on the system increased. Why the load on the system? आपण काही तिथं ओझं जास्त टाकलं नाही. But now it has to not only move on a plain road, but it has to go against the gravity. So it will be requiring more energy, more power. So here we say the load is increased. And in order to comply with this particular load, what the engine has to do then? Engine has to produce more power. And engine has to come to know that now the change in the power power has been, or requirement of the power has been changed. आता पॉवरची रिक्वायरमेंट चेंज झाले हे इंजिनला कळायला पाहिजे. आणि ते कळण्यासाठी आपण एक तिथं डिव्हाइस दिलं, त्याचं नाव आहे गव्हर्नर. So the device which you are using to respond, help the engine to respond, this is what you call as a governor, and the process of managing this particular response is what you call as a governing. Okay, and the governing is being done in the engine by changing the quantity of the mixture. म्हणजे ज्या ज्या वेळेला आपल्याला पॉवरची रिक्वायरमेंट वाढेल त्या वेळेला आपण काय वाढवणार आहे? मिक्सचरची क्वांटिटी वाढवणार आहे. And therefore the engines are called as quantity governed. Therefore the engines are called as quantity governed. And SI engines are quantity governed engines. म्हणजे SI engine मध्ये गव्हर्निंग आपण क्वांटिटी वाढवून करतो. याचा अर्थ असा आहे मिक्सचरची क्वांटिटी वाढवून आपण इंजिनला गव्हर्न करतो. म्हणजे SI engines are quantity governed. If you have understood, give me the confirmation. If you are not understood, please ask the doubt. Yes. If you are understood, please give the confirmation. If you are not understood, please ask the doubt. Anybody? Before moving ahead. Yes. Please.
सर चोक मधून एअर इनलेट रेट कॉन्स्टंट असतो का आपण थ्रोटल वॉल्व मधून बाहेर घेतो त्या डिपेंड वर असतो?
ठीक आहे. Okay, so his doubt is related to air coming in. Say we are talking of supplying the air fuel mixture to the engine. Whatever is being supplied, that has to be replaced. Correct? So we are talking in the previous lecture, we are talking of the mass of air, mass flow rate here and here remains constant. म्हणजे जेवढे मास इथनं आत येते तेवढे इथनं गेलं पाहिजे. म्हणजेच इन द रिव्हर्स इथनं जेवढं बाहेर जाईल तेवढं इथनं परत आतमध्ये आलं पाहिजे. So if you start here supplying more mixture, obviously more air will come in. It has to come because we are preparing the mixture of air fuel here with the help of the air coming from here. So if you want to supply more air fuel mixture, then more air has to come. If you want to supply less air fuel mixture, then less air has to come. That is it. Is have I cleared the point?
Yes sir, clear.
Okay. Any other doubt? Anybody having any other doubt related to quantity governing? Related to quantity governing? Related to this particular 4 points, provision for sucking in the air. आता माझा प्रश्न जर असा असेल, how the air is sucked, you should be in a position to answer. How the fuel is being brought into the carburetor, you should be in a position to answer. How the air fuel mixture is being prepared in the carburetor, you should be in a position to answer. How the air fuel mixture is being supplied as in the required quantity to the carburetor, you should be in a position to answer. या चारही प्रश्नाचे उत्तर कोणाला सगळ्यांना येत आहेत का? ज्यांना येत नाही त्यांनी मला डाऊट विचारा. Anybody is not able to answer this particular 4 questions can ask your doubts. Provision for sucking in the air. काय प्रोव्हिजन आहे बाबा आपल्याला कार्बोरेटर मध्ये एअर सक करण्यासाठी? What is the provision for bringing the fuel into the carburetor? How the air fuel mixture is being prepared in the carburetor, and how to ensure that proper quantity of air fuel mixture is being supplied to the engine. 4 प्रश्न विचारलेले आहेत. 4 प्रश्नांपैकी कुठल्याही प्रश्नाचं उत्तर येत नसेल तर यू कॅन टेल मी. We can go for once again explanation before going further. Yes, everybody has understood this answer of this particular 4 questions. I want confirmation. I want confirmation from your end. Everybody. Either you unmute yourself and tell me yes or no, or ask your doubt, please. Abhijit Rajput. Abhijit Rajput, can unmute yourself. Abhijit Rajput. Rajput, Abhijit. Please. Please. Tell me what is the provision for bringing in the fuel? Abhijit, question to you. फ्युएल कार्बोरेटर मध्ये आणण्यासाठी काय व्यवस्था केली आपण? अभिजित.
सर मेन जेट ओपन केल्या वेंचुरी.
मेन जेट ओपन केलंय. मेन जेट ओपन केलं तर कशाने ओपन करणार? आणि ओपन केलं तर आपोआप वेंचुरी न ओपन करतोय आपण. म्हणजे इथं दाखलेलं होतं अगोदर, बंद केलेलं होतं आणि नंतर आपण ओपन करतोय असं म्हणायचं आहे का तुम्हाला इथं? तसं काय नाहीये. हे जेट कायम ओपन आहे. मग फ्युएल कशी येणार? कशामुळे फ्युएल आतमध्ये येते? Why the fuel is coming in? What is the provision made to bring the fuel?
Pressure difference.
Correct. So what we have done, we have created pressure difference. What is the pressure difference? Here we have created a negative pressure. Here the pressure is positive, and for that we have entered this. Either positive झालं pressure, either negative झालं. So there is a pressure differential created, and due to this particular pressure difference, what is happening? Pressure difference. Due to pressure difference, fluid will flow in the direction from where the pressure is higher to the where the pressure is low. बरोबर? आपण ज्या वेळेला कोल्ड ड्रिंक पितो त्यावेळेला what we are doing, we are sucking in the air from the straw मधली एअर आपण सक केली आणि आपल्या तोंडामधले जी व्हॅक्यूम क्रिएट केलं when we suck. करेक्ट? मग काय झालं? आतमध्ये नेगेटिव्ह प्रेशर क्रिएट झालं. कोल्ड ड्रिंकच्या वरच्या बाजूला ऍटमॉस्फेरिक ऍक्ट होतंय. काय होणार? त्यामुळं the fluid, the cold drink starts moving through the straw into our mouth. Okay, when we suck, we are creating negative pressure. Atmospheric pressure is acting on the cold drink surface in the bottle. बरोबर. मग आपण ज्यावेळेला सक करतो त्यावेळेला काय करतो, वी आर क्रिएटिंग द प्रेशर डिफरन्स. सिमिलर प्रेशर डिफरन्स वी आर क्रिएटिंग हिअर. इथं सुद्धा आपण तेच केलं. काय केलं, इथं नेगेटिव्ह प्रेशर तयार केलं, इथं पॉझिटिव्ह प्रेशर तयार केलं. आणि ह्या पॉझिटिव्ह प्रेशर आणि नेगेटिव्ह प्रेशर म्हणजेच प्रेशर डिफरन्स मुळे काय झालं, फ्लुइड स्टार्ट्स फ्लोइंग इन दिस डायरेक्शन. आणि ज्या वेळेला ह्या प्रेशर डिफरन्स सफिशियंट इनफ असेल त्यावेळेला याच्यातून काय येणार, जेट फ्युएल विल कम आउट इन द फॉर्म ऑफ ए जेट. अभिजित 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 हा, can you explain once again what I have explained? Don't mute, please unmute and tell me the answer. Abhijit. अभिजित अभिजित तुमचा व्हिडिओ आणि ऑडिओ दोन्ही चालू करा आणि मला उत्तर सांगा. आता मी जे काही सांगितलं ते मला समजू द्या, तुम्हाला समजलंय का नाही ते. लेट मी अंडरस्टँड वेदर यू अंडरस्टूड ऑर नॉट.
हा सर समजलं.
हा सांगा बरं काय समजलं ते. अनम्यूट करा, व्हिडिओ ऑडिओ दोन्ही अनम्यूट करा आणि मला सांगा. अभिजित
समजले सर.
अहो पण सांगा की काय समजलंय ते. तुम्ही लगेच का म्यूट करताय, सांगा की काय समजलंय ते. मी तुम्हाला प्रश्न विचारलं सांगा म्हणून. मी आता जे काही सांगितलं ती रिपीटली मला सांगा तुम्ही.
सर समजलं, तुम्ही सांगा.
अहो मग सांगा ना. आता मी जे सांगितलं ते एकदा तुम्ही रिपीट करा म्हणजे मला समजेल की तुम्हाला समजलंय काय ते.
समजले.
अहो नुसतं समजलं म्हणून सांगू नका, मला सांगा की तुम्ही काय समजलं ते सांगा. आता तुमच्या स्क्रीनवर ते आता इथं कार्बोरेटर दिसतोय तुम्हाला, बरोबर. हा मग मला सांगा आता काय त्यात कशी काय व्यवस्था केली आपण फ्युएल आतमध्ये खेचण्यासाठी. तुम्हाला आता उदाहरणासहित सांगितलं मी काय केले ते. तेच गोष्ट तुम्ही मला सांगा परत. काय केलंय आपण. अभिजित
रिपीट करा परत.
अजून एकदा मीच रिपीट करू. बर ठीक आहे. मग माझं रिपीटेशन झालं की परत तुम्ही मला समजावून सांगायचंय, बरोबर. हा ठीक आहे. आपण ज्या वेळेला हा बोला.
हॅलो सर, आम्ही ते निगेटिव्ह आणि पॉझिटिव्ह प्रेशर कसं तयार करतो सर, नेमकं ते पद्धत कशी आहे सर त्याची.
तेच तुम्हाला सांगितलं, उदाहरणासहित सांगितलं. आपण ज्या वेळेला हवा आतमध्ये ओढतोय तोंडातून सक करतोय त्यावेळेला आपण आतमध्ये काय क्रिएट करतोय, नेगेटिव्ह प्रेशर क्रिएट करतोय. आणि बाहेरचा प्रेशर आहे तो पॉझिटिव्ह प्रेशर आहे. म्हणजे कमी प्रेशर असणं म्हणजे नेगेटिव्ह प्रेशर आणि जास्त प्रेशर असणं म्हणजे पॉझिटिव्ह प्रेशर, बरोबर. पॉझिटिव्ह प्रेशर आणि नेगेटिव्ह प्रेशर आपण कशाच्या तुलनेने सांगतोय, ऍटमॉस्फेरिकच्या कंडिशन, बरोबर आहे. आता पॉझिटिव्ह प्रेशर आपण कुठला धरतोय किंवा हाय प्रेशर कुठला धरतोय, बाहेरचा ऍटमॉस्फेरिक कंडिशन. आणि तुलनेनं आपण कमी प्रेशर कुठं तयार केलं, आतमध्ये तोंडामध्ये म्हणा किंवा आपल्या रेस्पिरेटरी सिस्टम मध्ये म्हणा. हाऊ वी आर क्रिएटेड बाय आयदर द इन्क्रीज द व्हॉल्यूम ऑफ द लंग्स, बरोबर आहे. आतला आपण ज्या वेळेला व्हॉल्यूम वाढवलं, सक केलं, त्यावेळेला आपण काय केलं, आतमध्ये व्हॉल्यूम वाढवलं. आतमध्ये व्हॉल्यूम वाढवलं त्यामुळे काय झालं, आतमधला प्रेशर, when the volume increases pressure decreases. ओके, आतमधला प्रेशर कमी झाला, बरोबर. आतमधला प्रेशर कमी झाला, बाहेरचा प्रेशर जास्त आहे. मग काय होणार, फ्लुइड स्टार्ट्स फ्लोइंग फ्रॉम हाय प्रेशर रिजन टू लो प्रेशर रिजन. ओके, बरोबर. जसं स्ट्रॉ मध्ये आपण केलं, काय केलं, विसकड आपण आतमधली जी स्ट्रॉ मध्ये जी एअर आहे त्याला सक केली. मग तिथं काय झाली, पोकळी तयार झाली, बरोबर. आता तिथं पोकळी तयार झाली म्हणजे काय झालं, नेगेटिव्ह प्रेशर क्रिएट झालं. आणि बाहेर काय आहे, पॉझिटिव्ह प्रेशर आहे. म्हणजे आतल्या स्ट्रॉ मधल्या आतल्या तुलनेनं ऍटमॉस्फेरिक प्रेशर हाय आहे. म्हणजे स्ट्रोच्या एका बाजूला जी लिक्विड आहे ती लिक्विड ऍटमॉस्फेरिक प्रेशर मध्ये आहे आणि दुसऱ्या बाजूला आपण माउथ मध्ये आहे, माझ्या आपल्या तोंडामध्ये आहे, तिथं नेगेटिव्ह प्रेशर आहे. त्यामुळे काय होईल, त्या स्ट्रॉ मधून कोल्ड ड्रिंक पास होईल. ओके, हिअर इथं पण तेच केलं, इथं पण आपण एक स्ट्रॉ लावली आणि या स्ट्रॉला काय म्हणतोय आपण, मेन फ्युअल जेट. बरोबर. आणि इथं काय केलं, इथं नेगेटिव्ह प्रेशर तयार केलं वेंचुरी लावून. मग आता काय झालं, ह्या स्ट्रॉच्या ह्या मेन जेटच्या या एंडला नेगेटिव्ह प्रेशर आहे, इथं पॉझिटिव्ह प्रेशर आहे, इथं प्रेशर डिफरन्शियल आहे आणि ह्या प्रेशर डिफरन्स मुळे काय झालं, फ्युअल स्टार्ट फ्लोईंग आउट. अभिजित.
येस सर.
हा, आता एक्सप्लेन का, अजून समजून सांगू परत एकदा.
नाही सर.
हा सांगा मग.
म्हणजे कसं ते राईट साईडला प्रेशर त्या बॅरल मध्ये प्रेशर निगेटिव्ह आहे.
हा.
आणि बाहेरच्या साईडला ऍटमॉस्फिअर प्रेशर जास्त असतंय म्हणून ते
बाहेरच्या साईडला म्हणजे
एअर जे
इथं का, बाहेर म्हणजे कुठे, इथं
इथं ते सर
कुठं आपल्याला हे,
राईट साईडला.
हा
इथून वर घेऊन जायचं प्रेशर
इथं,
हो,
अप्पर साइड ऑफ द फ्युएल.
इथं पॉझिटिव्ह प्रेशर असतं आणि इथं या साईड लेफ्ट साईडला
नेगेटिव्ह प्रेशर.
निगेटिव्ह असतं.
त्याच्यामुळे काय झालं,
त्यामुळे ते पॉझिटिव्ह टू निगेटिव्ह कडे ते प्रेशर गेलं.
बरोबर, करेक्ट. आता आपण ज्या वेळेला समजा मी एक पाईप घेतली आणि त्या पाईप मधून फुकायला लागलो, फुकल्यानंतर काय होतंय, आय एम क्रिएटिंग पॉझिटिव्ह प्रेशर इनसाइड माय माउथ आणि माझ्या तोंडामध्ये पॉझिटिव्ह प्रेशर आहे बाहेरच्या ऍटमॉस्फेरिक प्रेशर पेक्षा. त्यामुळे काय झालं, त्या स्ट्रॉ मधून हवा किंवा जी काही फ्लुइड असेल ती बाहेर येईल. बरोबर. आपण पिचकारी मारतो, काय करतो, आतमध्ये जास्त प्रेशर जास्त क्रिएट करतो आणि बाहेरच्या प्रेशर पेक्षा त्या वेळेला ती पिचकारी बाहेर येते. ओके, इन अ सिमिलर मॅनर हियर द फ्युअल इज बीइंग कमिंग आउट इन द फॉर्म ऑफ ए जेट. बरोबर, करेक्ट. अभिजित, अंडरस्टूड?
हा सर.
ओके ओके. नाउ कापसे, अनिकेत कापसे. अनिकेत कापसे.
Yes.
Now you tell me how the mixture is being prepared in the carburetor.
Sir, first the air comes, then through this tanker, fuel comes. The energy of air is sucked by fuel droplets.
Heat.
And heat is produced. And
heat is produced.
Mixture.
Heat cannot produce. Energy cannot be produced. Rule at
means this fuel droplets.
Please.
Fuel droplets suck energy.
Okay.
This air. Heat.
Then what happens? Due to that energy, what happens? मराठीमध्ये सांगा. मराठीमध्ये सांगा. मराठीमध्ये सांगा. ड्रॉपलेट्स काय करते? हीट ऍब्सॉर्ब करते.
एअर
ठीक आहे. Okay. So what according to her is the droplets are going to absorb the heat from the air. Okay, and when that heat is reaching the fuel, the liquid fuel is being converted into vapor. And once the liquid fuel is being produced, the vapor of the fuel mixes with the air to form the air fuel mixture. Okay, that is how the mixture is being prepared here. Okay, in the venturi. So why we have provided the venturi? To prepare the air fuel mixture. Okay, first its function was to suck in the fuel and to prepare the air fuel mixture. Hope that everybody has understood all the four questions over here. How the air is being sucked, how the fuel is being sucked, how the mixture is being prepared, and how we are able to supply the air fuel mixture. One more question I will ask to Anil Dongre. Can you unmute yourself? Anil Dongre. Anil Dongre. Anil. Anil Dongre. Dongre Anil. Can you unmute yourself? सकाळ सकाळी अनिल झोपला का? अनिल सकाळ सकाळी झोपला? दीक्षा आदमिले. हाँ. Why
Yes,
SI engines are called as quantity governed engines?
Huh?
Why SI engines are called as quantity governed engines? SI engine ला आपण quantity governed engine असं का म्हणतो?
because of they respond to.
Come on, you are right.
म्हणजे एखादं म्हणजे लोड वाढत असेल तर त्याला ते सपोर्ट करतं म्हणजे.
कसं सपोर्ट करतं?
तुम्ही एक एक्झाम्पल सांगितलं होतं की जर तहान लागली तर आपण पाणी पितो तसं ते एनर्जी वाढतं म्हणजे ही काय म्हणतात एनर्जी प्रोड्यूस करतो.
बर. जिथं लोड वाढला आपल्याला काय चेंज करतोय आपण? इंजिन वरती लोड वाढला, काय चेंज करायचंय आपल्याला? पॉवर जास्त करायची. ते पॉवर जास्त करायसाठी आपल्याला काय करायला पाहिजे? पॉवर वाढवायचे. मग पॉवर जास्त वाढवायसाठी काय करायला पाहिजे?
फ्युएल मिक्सचर जास्त लागलं.
करेक्ट. द क्वांटिटी ऑफ द मिक्सचर सप्लाइड इज मोर. आणि ती कशाच्या हेल्पने आपण करतोय? गव्हर्नरच्या हेल्पने. बरोबर. म्हणून आपण त्याला काय म्हणतो? So since the governing is done by increasing or decreasing the quantity of the mixture, the engine is called as quantity governed engine. Clear?
Yes.
Okay. So SI engines are quantity governed. I hope everybody understood the point. How we can call the SI engines as quantity governed engines. Now moving ahead, we will go for the next point. So this is your different components as we have discussed. Now let us move on to discuss different systems in a simple carburetor. Different systems in a simple carburetor. Okay. So what are the different systems? So this is a simple carburetor, something like we have a main metering jet system. Main metering system it is called as. What is main metering system? That system which meters the fuel and supply to the engine is called as main metering system. Okay, which is connected to main jet, and therefore the word main is coming. And where the word metering is coming? Because it is measuring the fuel supplied to the carburetor. So a system is provided which helps to ensure that measured quantity of the fuel is being supplied to the engine, and that system is called as main metering system. It consists of a main jet and the pipeline connecting the main jet with the float chamber, which has a float in it with a needle valve. Okay, and this particular system is what you call as main metering system. So this particular pipeline with the main jet is called as main metering system, and what it does, it ensures fuel supply to the carburetor in the required quantity and as and when required. Okay, so that is your main metering system. Second system is your float system. Float system, what it does? It maintains the fuel level in the float chamber. फ्लोट चेंबर मधलं लेवल जे आहे ते मेंटेन करायचंय आपल्याला, एक फिक्स्ड लेवलला मेंटेन करायचं आणि ते कोण करतं? फ्लोट सिस्टम करतं. म्हणजेच काय? whenever the float goes down, when it goes down, when the level in the level of the fuel in the float comes down. So when the ही level ज्या वेळेला खाली जाईल, when the level of the fuel in the float chamber comes down, the float also goes down along with it. And whenever this float goes down, the needles comes out of this particular pipeline through which the fuel is coming in, and therefore it allows the fuel to flow into the float chamber. And what it does by doing so, it maintains the fuel level in the float chamber. It ensures that it is going to be fixed. नेहमी fuelची level एवढीच आहे हे मेंटेन करण्यासाठी कोण आहे तिथं? Fuel system आहे. Okay, float system आहे. So what is the function of the float system? The function of the float system is to maintain the fuel level, constant fuel level in the float chamber. Okay, so that is float system. Third system is your throttle system. What the throttle system does? It ensures the supply of required air fuel mixture to the engine, required quantity of air fuel mixture to the engine. Okay, it ensures the supply of required quantity of air fuel mixture to the engine. Who is doing this function? It is done by throttle system. Okay, so throttle system ensures that the required air fuel mixture is being supplied to the engine. Float system ensures that a fixed level of the fuel is maintained in the fuel float chamber, and main metering system ensures that the fuel is being supplied as and when required in order to prepare the air fuel mixture. म्हणजे मेन मीटरिंग सिस्टम काय करते? फ्युएल जेवढ्या क्वांटिटीत पाहिजे तेवढ्या क्वांटिटीत ज्या वेळेला पाहिजे त्या वेळेला सप्लाय करते, आणि त्या सिस्टमचं नाव आहे मेन मीटरिंग सिस्टम. आणि मेन मीटरिंग सिस्टम मध्ये काय काय आहे? एक जेट आहे, मेन जेट आहे, आणि त्याला कनेक्ट केलेल्या पाइपलाइन आहे जे का फ्लोट चेंबरला कनेक्ट केली दुसऱ्या साइडला. ओके, त्याला मेन मीटरिंग सिस्टम असं म्हणायचं. सेकंड सिस्टम इज फ्लोट सिस्टम. फ्लोट सिस्टम काय करते? एन्श्योर्स द लेवल ऑफ द फ्युएल इन द फ्लोट चेंबर इज मेंटेन्ड कॉन्स्टंट. इथलं लेवल खाली किंवा जास्त किंवा वर न होऊ देणं ही कोणाचं काम आहे? फ्लोट सिस्टमचं काम आहे. ते कसं करतंय? हे फ्लोट जर खाली आला, ही कधी खाली येईल? ज्या वेळेला लेवल खाली येईल. लेवल खाली आले की फ्लोट खाली आला. फ्लोट खाली आला की काय होणार? निडल बाहेर येणार. निडल बाहेर आले की फ्युएल आतमध्ये येणार. बरोबर? जर लेवल वरती गेली काय होणार? हे निडल आतमध्ये जाणार. निडल आतमध्ये गेली की आतमध्ये इकडून येणारी फ्युएलची क्वांटिटी आहे ती कमी झाली, आणि ही जर रिक्वायर्ड लेवलला पोहोचेल त्यावेळेला ही निडल एवढ्या प्रमाणात आतमध्ये जाणार की इकडून फ्युएल येऊ शकत नाही. Okay, so that is the function of the float system. And the third system is throttle system. Throttle system चं काम काय आहे? It ensures proper quantity of air fuel mixture supplied to the engine as and when required. ज्या वेळेला जेवढी क्वांटिटी पाहिजे तेवढी क्वांटिटी इंजिनला सप्लाय करणं कोणाचं काम आहे? थ्रोटलचं काम, थ्रोटल सिस्टमचं काम. ओके, सो दीज आर द 3 subsystem of your simple carburetor. Limitations of a simple carburetor. आता इथे काय लिमिटेशन्स आहेत? आता लिमिटेशन समजायच्या अगोदर अजून थोडंसं वर्किंग रिलेटेड समजून घेऊया. आपण जे काय समजून घेतलं इथं बघा, आपण here we have shown the arrows. This arrows indicates that air is coming in. Air is now changed its direction. That means the path of the air is being now decreasing. Convergent. Okay, convergent section. It's a convergent type. Okay, so in this region it is convergent. That means it is decreasing. कुठपर्यंत? थ्रोट पर्यंत. थ्रोट म्हणजे काय? मिनिमम डायमीटर असलेल्या सेक्शनला आपण थ्रोट म्हणतो. थ्रोट पर्यंत डायमीटर कमी होत चाललाय, थ्रोट नंतर डायमीटर वाढत चाललाय. ओके, मग आता काय झालं, समजा इथून मार्च पास्ट येते. मार्च पास्ट माहितीये तुम्हाला सगळ्यांना, आपण लेफ्ट राईट करतो, चालतो, त्याला मार्च पास्ट म्हणतात, मिलिटरी मार्च पास्ट. आता इथून समजा मिलिटरी मार्च पास्ट आहे आणि इकडे जायचंय, तर इथं काय होणार, इथनं येताना इथं अशा लाईन्स मध्ये इथे एक लाईन, इथे एक लाईन, इथे एक लाईन, अशा लाईन्स मध्ये चालतो. इथं सुद्धा 1 2 3 4 तेवढीच डायमीटर असल्यामुळे तेवढ्या लाईन शक्य आहे. परंतु इथं काय होईल, इथं आलं की या लोकांना काय करावं लागेल, अचानक इथं पळत येऊन परत माघारी इथं जॉईन त्यांच्या लाईनला यावं लागेल. करेक्ट? वाय? वी आर एन्श्युरिंग दॅट मास फ्लो रेट ऑफ हिअर अँड हिअर इज मेंटेन्ड कॉन्स्टंट. बरोबर आहे का? इथला मास फ्लो रेट आणि इथला मास फ्लो रेट आपल्याला कॉन्स्टंट मेंटेन करायचं. आणि त्यासाठी ज्या वेळेला एअर इथून पास होईल त्यावेळेला इथं त्याची स्पीड वाढवावं लागते, वेलॉसिटी वाढवावं लागते. बरोबर? तर I hope everybody understood why we have to increase the velocity. Why we have to increase the velocity? Because we have to ensure that mass flow rate has to be maintained constant. आणि मास फ्लो जर मेंटेन कॉन्स्टंट नाही झाला तर काय होईल, इकडून जेवढी येते तेवढे इकडे जाणार नाही. बरोबर? म्हणजे इथं मास फ्लो रेट कमी होईल. परंतु आपल्याला ती मेंटेन करायचं आहे, म्हणजेच काय, तर इथं या कमी एरिया असलेल्या सेक्शन मध्ये, कमी क्रॉस सेक्शन, कमी डायमीटर असलेल्या क्रॉस सेक्शन मध्ये आपल्याला त्याची वेलॉसिटी वाढवून त्याचा मास फ्लो रेट आपण कॉन्स्टंट ठेवतो. वेलॉसिटी वाढवून त्याचा मास फ्लो रेट कॉन्स्टंट ठेवतो. म्हणजेच काय, तर आपल्याला वेलॉसिटी वाढवावं लागते. करेक्ट? सो इन ऑर्डर टू इन्क्रीज द कायनेटिक एनर्जी, वेलॉसिटी वाढवायचं म्हणजे कायनेटिक एनर्जी वाढवायची. कायनेटिक एनर्जी वाढवायला तर आपल्याला कायनेटिक एनर्जी तिथं कुठेतरी द्यायला पाहिजे. आता इथल्या एअरला, इथं येणाऱ्या एअरला, आपण व्हेंचुरी मध्ये येणाऱ्या एअरला कायनेटिक एनर्जी कुठून देणार? वी कॅनॉट सप्लाय द कायनेटिक एनर्जी टू हिअर. मग आपण काय करणार? सो that is why we have provided here venturi. And what happens in the venturi then? In the venturi, in the conversion session, the pressure energy gets converted into kinetic energy. Pressure energy gets converted into kinetic energy. का? Thermodynamic law सांगतोय, energy cannot be created nor it can be destroyed. It can be only converted from one form to another. तिथं आपल्याला एनर्जी पाहिजे. कुठली एनर्जी पाहिजे? कायनेटिक एनर्जी पाहिजे. परंतु इथं जाऊन आपण आतमध्ये जाऊन कायनेटिक एनर्जी देऊ शकत नाही. मग काय होणार? इथं काय होतंय, कारण इथं मास फ्लो रेट आणि इथं मास फ्लो रेट दोन्ही साईडला, व्हेंचुरीच्या दोन्ही साईडला मास फ्लो रेट आपल्याला कॉन्स्टंट ठेवायचा आहे. सो इन ऑर्डर टू मेंटेन द मास फ्लो रेट ओव्हर हिअर अँड हिअर कॉन्स्टंट, हिअर द एअर हॅज टू इन्क्रीज इट्स वेलॉसिटी. आणि ती वेलॉसिटी इन्क्रीज करण्यासाठी आपण प्रेशर सॅक्रिफाईस केला, प्रेशर एनर्जी सॅक्रिफाईस केली. Pressure energy is getting converted into kinetic energy. So that is how the air is able to increase its kinetic energy. म्हणजे आपल्याला एअरची कायनेटिक एनर्जी, वेलॉसिटी वाढवण्यासाठी प्रेशर सॅक्रिफाईस करावा लागला. And that is how at the throat we have, म्हणजे व्हेंचुरीच्या थ्रोट मध्ये आपलं प्रेशर मिनिमम असणार आहे. का? जसं पुढे येईल तसं जास्त प्रमाणात प्रेशर एनर्जी कमी होऊन जास्त प्रमाणात वेलॉसिटी वाढत जाईल. वेलॉसिटी सो म्हणजे थ्रोट पर्यंत आल्यानंतर काय असणार आहे, वेलॉसिटी मॅक्झिमम असणार आहे आणि प्रेशर मिनिमम असणार आहे. सो ऍट थ्रोट ऑफ द व्हेंचुरी वी विल हॅव मॅक्झिमम वेलॉसिटी, दॅट इज मॅक्झिमम कायनेटिक एनर्जी अँड मिनिमम प्रेशर एनर्जी वेन कम्पेअर्ड टू इनलेट. म्हणजे ह्या व्हेंचुरीच्या इनलेटच्या तुलनेनं इथला एनर्जी जर कन्सिडर केलं, इथं काय प्रेशर एनर्जी आणि कायनेटिक एनर्जी आहे एअरकडे, त्या तुलनेनं इथं गेलं तर कायनेटिक एनर्जी मॅक्झिमम असणार आहे आणि प्रेशर एनर्जी मिनिमम असणार. कारण इथून पुढे जसं जाईल तसं प्रेशर एनर्जीचं कायनेटिक एनर्जी मध्ये कन्व्हर्जन होतं. कशासाठी? कारण आपल्याला इथं मास फ्लो रेट मेंटेन करायचं आहे आणि मास फ्लो रेट मेंटेन करण्यासाठी आपल्याला प्रेशर एनर्जी सॅक्रिफाईस करून त्याचं कन्व्हर्जन कायनेटिक एनर्जी मध्ये करावं लागतंय आणि त्यामुळे कायनेटिक एनर्जी वाढते, म्हणजेच वेलॉसिटी वाढते. इथं वेलॉसिटी वाढली आणि इथं मिनिमम सेक्शनला, ज्या सेक्शनला इथं डायमीटर मिनिमम असेल तिथं काय होतंय, कायनेटिक एनर्जी इज मॅक्झिमम अँड प्रेशर एनर्जी इज मिनिमम. करेक्ट? आणि त्या सेक्शन मध्ये आपण हा जेट ओपन केलाय, जेट ओपन केलाय बरोबर. कुठल्या सेक्शन मध्ये? जिथं वेलॉसिटी मॅक्झिमम आहे आणि काय प्रेशर एनर्जी मिनिमम आहे. मग काय झालं, इथलं नेगेटिव्ह प्रेशर म्हणजे मिनिमम प्रेशर आणि इथलं पॉझिटिव्ह प्रेशर म्हणजे हायर प्रेशर, त्याच्यामुळं फ्युएल विल कम आउट. ओके, सो दॅट इज हाऊ द so when the pressure difference is more higher, कारण समजा थोडा प्रेशर डिफरन्स क्रिएट केला तर काय होईल, आपण म्हणलं की इथं ही लेवल आहे म्हणल्यानंतर इथं लेवल इथंपर्यंत येईल. आता थोडासा प्रेशर डिफरन्स केला तर काय होईल, हे वरती वाढेल 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 इथंपर्यंत येईल, पण तरी सुद्धा ती बाहेर येऊ शकणार नाही. मग अजून प्रेशर डिफरन्स वाढवला, मग काय होणार, ते बाहेर असं फ्लो व्हायला चालू, असं फ्लो व्हायला चालू. अजून प्रेशर वाढवला तर काय होणार, हे जे म्हणजे थोडीशी पिचकारी येईल. आणि अजून प्रेशर वाढवलं तर काय होईल, दिस विल बी इन द फॉर्म ऑफ अ स्प्रिंग. So the amount of pressure difference here and here is going to decide how the fuel is going to come out. And when the pressure differential between the venturi throat and the float chamber is sufficient enough, at that time the fuel will come out in the form of a spray. So while designing a carburetor, we have to keep in mind that the pressure differential should be such that the fuel has to come out in the form of a jet spray. Okay, so because we want to convert the fuel into fuel droplets, कारण fuel droplets मध्ये convert केलं तरच it is able to suck the heat, and when it's able to suck the heat, it is going to convert into vapor. So that is how we have a system which we call as a simple carburetor, and this particular simple carburetor have some disadvantages. So let us now discuss the disadvantages of a simple carburetor. Disadvantages or limitations. So this is your simple carburetor, and first limitation is, as the throttle is open, it starts supplying progressively rich mixture. म्हणजे काय, म्हणजे जसं हा थ्रोटल जास्त आपण ओपन करत जाऊ तसं ते जास्त प्रमाणात मिक्सचर सप्लाय करायला चालू करेल प्रोग्रेसिव्हली. प्रोग्रेसिव्हली म्हणजे जसं थ्रोटल आपण जास्त प्रमाणात प्रोग्रेसिव्हली ओपन करत जाऊ, इनिशियली बंद केलेला आहे, इनिशियली इट इज क्लोज अँड प्रोग्रेसिव्हली वी आर ओपनिंग इट मोर अँड मोर. म्हणजे जसं प्रोग्रेसिव्हली आपण त्याला ओपन करत जाऊ तसं प्रोग्रेसिव्हली ते मिक्सचर क्वांटिटी सप्लाय काय करते, रिच करते. रिच, रिच म्हणजे काय, मोर फ्युअल. लीन म्हणजे काय, लेस फ्युअल मोर एअर. ओके, सो व्हेन द मिक्सचर इज हॅव्हिंग मोर फ्युअल when compared to air, it is called as rich. When the fuel is having more air when compared to the standard, म्हणजे समजा आता स्टँडर्ड एक तुम्ही ठेवली, एक ठराविक एअर आहे आणि ठराविक प्रमाणात फ्युअल आहे. म्हणजे समजा suppose the air fuel mixture is 10:1. What we said, 10 quantity of air and 1 quantity of fuel. 10 units of air and 1 unit of fuel is called as 10:1 air fuel ratio. आणि त्या एअर फ्युअल रेशोला आपली सिस्टम डिझाइन केली बरोबर. नाउ what happens, we are saying of rich mixture. Rich mixture म्हणजे काय, आता 10 quantity of air this round, instead of 1 quantity of fuel, it can become 2 quantity of fuel or 1.5 quantity of fuel. Then we call it as rich mixture. म्हणजे जेवढ्या प्रमाणात फ्युएल पाहिजे होते त्याच्यापेक्षा जास्त प्रमाणात फ्युएल आपण सप्लाय करायचं. Then we call it as a rich mixture. And another type of mixture is lean mixture. What is this lean mixture? Lean mixture means 10:1. म्हणजे 10 क्वांटिटी ऑफ फ्युएल एअरला 1 क्वांटिटी ऑफ फ्युएल सप्लाय करतो. पण आता काय झालं, 1 क्वांटिटी ऑफ फ्युएल तेवढंच राहिलं आणि 10च्या ऐवजी आपण 12 क्वांटिटी ऑफ फ्युएल युनिट्स ऑफ फ्युएल सप्लाय करायला चालू केलं. नाउ द fuel mixture becomes 12:1. 12:1. Then it is called as a lean mixture. Okay, but here the problem what we are talking of rich mixture. Okay, what is the problem coming? Progressively, म्हणजे जसं आपण टोटल ओपन करत जाऊ तसं मिक्सचर रिच व्हायला चालू होते. आपल्याला काय अपेक्षित होतं, मोर क्वांटिटी ऑफ मिक्सचर सप्लाय होणं अपेक्षित होतं. मोर क्वांटिटी ऑफ द मिक्सचर, क्वांटिटी ऑफ द मिक्सचर सप्लाय मोर करणं अपेक्षित होतं आणि काय चेंज होतंय, क्वालिटी चेंज होतंय, रिच मिक्सचर होतंय. So when we are trying to supply more air fuel mixture by opening the throttle more, the mixture starts becoming more and more rich. Now why it is happening, we will explain. This particular problem is solved by what we call as a compensating system. आणि हा जो प्रॉब्लेम आहे हे सॉल्व करण्यासाठी आपल्याला कॉम्पन्सेटिंग सिस्टम यूज करावं लागतं. ओके, प्रॉब्लेम काय आहे, थ्रोटल जसं जास्त जास्त प्रमाणात ओपन करत जाऊ तसं मिक्सचर रिच व्हायला लागते, जी होणं अपेक्षित नाहीये परंतु होतंय. बरोबर, होणं अपेक्षित नाहीये, रिच होणं अपेक्षित नाहीये परंतु ते रिच होत जाते, जास्त प्रमाणात रिच होत जाते. बरोबर. So mixture as it is being supplied more and more by opening the throttle more and more, we are expecting that quality should remain constant but quantity only increases. But what is actually happening, along with the quantity, quality also is changing. It is becoming rich. It is becoming rich. That becomes a limitation. That becomes a limitation. जी अपेक्षित नव्हतं ती होत आहे. काय अपेक्षित नव्हतं, क्वालिटी चेंज करणं अपेक्षित नव्हतं. का अपेक्षित नव्हतं, कारण आपण ऑलरेडी सांगितलंय की SI इंजिन इज अ क्वांटिटी गव्हर्न्ड इंजिन. क्वांटिटी गव्हर्न्ड इंजिन. आपल्याला ज्या वेळेला जास्त पॉवर पाहिजे त्या वेळेला आपण मिक्सचरची क्वांटिटी वाढवणार आहे, क्वालिटी वाढवणार नाहीये, अपेक्षित नाहीये. परंतु होतंय काय, आपण क्वांटिटी वाढवायचा प्रयत्न करतोय परंतु क्वालिटी सुद्धा चेंज होते, क्वालिटी सुद्धा रिच होते. कार्बोरेटर स्टार्ट सप्लाइंग रिच मिक्सचर when the throttle is open. And what was supposed to happen when the throttle is open? When the throttle is opened more and more, it was supposed to supply more and more quantity of mixture. क्वांटिटी वाढवणं अपेक्षित होतं, परंतु जशी क्वांटिटी वाढवेल तसं क्वालिटी सुद्धा रिच व्हायला चालू होते, विच इज अ डिसएडवांटेज. कारण आपण अपेक्षित थेरॉटिकली काय करतोय की क्वालिटी सेम राहते आणि फक्त क्वांटिटी वाढत जाते. क्वालिटी सेम राहते आणि फक्त आपल्याला क्वांटिटी वाढवायचे. परंतु होतंय काय, व्हॉट इज हॅपनिंग, along with the quantity, the mixture is becoming more and more rich. So as when the throttle is being opened progressively, the mixture supplied by the carburetor starts becoming more and more rich. आणि हा प्रॉब्लेम सॉल्व करायसाठी आपल्याला मग अजून वेगळ्या वेगळ्या सिस्टम, आताशी 3 सिस्टम आपण डिस्कस केल्या. बरोबर आहे. कुठली सिस्टम आपण डिस्कस केलत्या, एक मेन जेट सिस्टम डिस्कस केलते, एक थ्रोटल सिस्टम डिस्कस केलते आणि तिसरे फ्लोट सिस्टम डिस्कस केलते. आता अजून एक सिस्टम आपल्याला वापरायची विच वी कॉल ॲज कॉम्पेन्सेटिंग सिस्टम. का कॉम्पेन्सेटिंग सिस्टम वापरावं लागते, कारण सिंपल कार्बोरेटर हा झाला तुमचा सिंपल कार्बोरेटर. ह्या सिंपल कार्बोरेटर मध्ये एक डिसएडवांटेज आहे आणि ते डिसएडवांटेज काय आहे, प्रोग्रेसिव्हली इट स्टार्ट सप्लाइंग रिच मिक्सचर व्हेन द थ्रोटल इज ओपन. जसं आपण ऍक्सेलरेटर देऊ तसं थ्रोटल जास्त जास्त ओपन होत जातो आणि जसं थ्रोटल ओपन होत जातोय तसं ते रिच मिक्सचर सप्लाय करायला स्टार्ट करतोय. हा त्याचा डिसएडवांटेज आहे, जे का होणं अपेक्षित नाहीये. आपल्याला काय अपेक्षित होतं, फक्त क्वांटिटी ऑफ द मिक्सचर इन्क्रीज वॉज एक्सपेक्टेड. फक्त क्वांटिटी इन्क्रीज करणं अपेक्षित होतं, परंतु काय होतंय, क्वालिटी सुद्धा चेंज होते. बरोबर, कारण मिक्सचर रिच होत जाते, जे अपेक्षित नव्हतं. म्हणजे मिक्सचर रिच न होता मिक्सचर ची क्वालिटी सेम, फक्त क्वांटिटी वाढवणं अपेक्षित होतं. परंतु होतंय काय, क्वांटिटी जशी वाढवत जातो तसं मिक्सचर सुद्धा रिच व्हायला चालू होते, म्हणजे क्वालिटी सुद्धा चेंज होते. आणि ते प्रॉब्लेम ओव्हरकम करण्यासाठी आपल्याला कॉम्पेन्सेटिंग सिस्टम्स वापराव्या लागतात. सो द फर्स्ट लिमिटेशन अँड इट्स सोल्युशन. ओके. सेकंड लिमिटेशन, ड्युरिंग कोल्ड स्टार्टिंग. सुरुवातीला सकाळ सकाळी आपण ज्या वेळेला गाडी स्टार्टिंग करतो त्याला म्हणतो आपण कोल्ड स्टार्टिंग. का? रात्रभर आपल्याला माहिती आहे आपल्याला थंडी वातावरण कंपॅरेटिव्हली कोल्ड असतं. ओके, बरोबर आहे. आणि त्यामुळे इंजिन सुद्धा कोल्ड असतं कारण इंजिन ऍटमॉस्फिअर मध्ये आहे. आणि ऍटमॉस्फिअर मध्ये ऑलवेज व्हॉट हॅपन्स, ऑलवेज हीट फ्लोज फ्रॉम अ हायर टेम्परेचर रिजन टू लोअर टेम्परेचर रिजन अंटिल द टेम्परेचर बिकम कॉन्स्टंट. म्हणजे जर इंजिन आपण ऍटमॉस्फिअर मध्ये ठेवलं तर फायनली काय होणार, इंजिन टेम्परेचर आणि ऍटमॉस्फिअरची टेम्परेचर सेम होणार. म्हणजे आता इंजिन सुद्धा कोल्ड आहे. का कोल्ड आहे? कारण ऍटमॉस्फिअर रात्री कोल्ड होतं. आता आपली कोल्ड इंजिन आपण स्टार्ट करायचा प्रयत्न करतो. अँड वॉर्मअप रिजन म्हणजे वॉर्मअप पिरियड म्हणजे कुठले पिरियड? ज्या वेळेला इनिशियली इंजिन रन होत आहे, चालू केल्या त्याला वॉर्मअप पिरियड म्हणतात. ओके. कोल्ड स्टार्टिंग करत असताना आणि वॉर्मअप पिरियड मध्ये काय, इट इज अनेबल टू प्रोव्हाइड रिच मिक्सचर. अपेक्षित काय? स्टार्टिंग and warm-up period, carburetor should be able to supply rich mixture. But what is happening? It is unable to supply rich mixture. ज्या वेळेला आपल्याला अपेक्षित नव्हतं त्या वेळेला ते रिच मिक्सचर सप्लाय करत आहे. परंतु ज्या वेळेला अपेक्षित आहे, कोल्ड स्टार्टिंग मध्ये रिच मिक्सचर अपेक्षित आहे, वॉर्मअप पिरियड मध्ये रिच मिक्सचर सप्लाय करणं अपेक्षित आहे, परंतु त्या वेळेला इट इज अनेबल टू प्रोव्हाइड रिच मिक्सचर. अँड टू ओव्हरकम दिस वी आर युझिंग चोक. व्हेरी 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 इम्पॉर्टंट. सो वाय वी आर युझिंग चोक? We will again explain this, how it is happening, how this particular problem is being solved, etc. परंतु हा प्रॉब्लेम सॉल्व करायसाठी आपल्याला एक चोक नावाचं एक वॉल्व आपल्याला वापरावं लागतंय. का वापरतोय आपण? कोल्ड स्टार्टिंग मध्ये ज्या वेळेला रिच मिक्सचर सप्लाय करणं अपेक्षित आहे, परंतु कार्बोरेटर तुमचा रिच मिक्सचर प्रोव्हाइड करू शकत नाही. कुठल्या कार्बोरेटर बद्दल बोलतोय आपण? सिंपल कार्बोरेटर बोलतोय. हे दिसतंय हे सिंपल कार्बोरेटर आहे. दिस इज whatever the figure is shown is simple carburetor, and this particular simple carburetor is unable to provide rich mixture during cold starting and during warm up, and therefore to overcome this problem we have to use choke. तर choke का वापरतोय? कारण carburetor is supposed to supply rich mixture during cold starting, but it is unable to do so, and we therefore to solve this problem we are using a device or a component what we call as a choke. तर इथं काय आपण डिस्कस केलं? सेकंड लिमिटेशन आणि त्याच्यावरचं सोल्युशन. थर्ड लिमिटेशन, ड्युरिंग आयडलिंग. आता त्यासाठी आयडलिंग म्हणजे काय समजायला पाहिजे. सो व्हॉट इज आयडलिंग? आयडलिंग इज आपण गाडी चालू केली, वी हॅव स्टार्टेड द इंजिन बट वी आर नॉट रनिंग द व्हेइकल. वी आर नॉट रनिंग द व्हेइकल. आवर ऍक्सेलरेटर इज ॲट झिरो पोझिशन. ऍक्सेलरेटर इज ॲट झिरो पोझिशन म्हणजे आपण ऍक्सेलरेटर बिलकुल दाबलेला नाहीये किंवा टू व्हीलर मध्ये असेल तर मूठ पिळलेले नाहीये. ओके, वी हॅव नॉट पुश द ऍक्सेलरेटर, इट इज ॲट झिरो पोझिशन, बट वी हॅव स्टार्टेड द इंजिन and the engine starts running. Duk, 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 duk. So very slowly it will be firing. But we are not running the engine. Sorry, we are not running the vehicle. We have not touched the accelerator. Accelerator is at zero position, but engine has been started. आपल्याला या कंडिशन कुठली असते? आपल्याला जनरली माहिती आहे, आपण गाडी चालू असतो आणि आपल्या सिग्नलला थांबतो. आपण गाडी बंद केलेली नाही, बरोबर आहे? गाडी बंद केलेली नाही, ऍक्सेलरेटर दिलेलं नाही कारण आपल्याला गाडी थांबवलेली आहे, बरोबर? सो गाडी तर थांबलेली आहे, परंतु इंजिन तर स्टार्ट आहे आणि ऍक्सेलरेटर आपण दाबलेलं नाही, म्हणजे गाडी आयडल मध्ये आहे. आणि या कंडिशन मध्ये या कंडिशनला आपण आयडलिंग कंडिशन म्हणतो. So this is your idling condition. You have started the engine, but you are not running the vehicle. Your accelerator is at 0 position. Okay, then you will call it as a idling. So very slowly the firing will take place. Duk, 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 duk. Very slowly the firing will take place. Where our aim is to just to provide that much energy to sustain the firing. म्हणजे आपल्याला फायरिंग कंटिन्यू राहावं, इंजिन चालू कंटिन्यू राहावं, तेवढ्या प्रमाणात फक्त पॉवर आपण तयार करणं अपेक्षित आहे. आणि ह्या आयडलिंग पिरियड मध्ये काय होतंय, लेस फ्युअल इज सप्लाइड बाय द जेट बट रिच मिक्सचर इज रिक्वायर्ड. मिक्सचर रिक्वायरमेंट रिच आहे. आता आयडलिंग मध्ये मिक्सचर रिक्वायरमेंट रिच काय आपण नंतर डिस्कस करू. रिक्वायर्ड काय आहे, रिच मिक्सचर कधी आयडलिंग मध्ये. परंतु जेट काय करते, इट इज अनएबल टू सप्लाय रिक्वायर्ड क्वांटिटी ऑफ फ्युएल. प्रॉब्लेम काय आहे, प्रॉब्लेम काय आहे, ड्यूरिंग आयडलिंग engine is requiring rich mixture, but your fuel system, main metering system, is unable to supply required amount of mixture. Okay, this is the problem. And what is the solution? This problem is solved by using a separate idling system in the carburetor. This problem is solved by using a separate idling system in the carburetor. So we are discussing the limitations of a simple carburetor. What were the limitations? First, as the throttle is open, whenever we push the accelerator, even though we are not expecting it to supply rich mixture, it is supplying rich mixture. We want to ensure quality should not change, but it is changing the quality. Okay, that is the problem. And that problem is solved by using compensating system in the carburetor. Second problem, during cold starting, it is unable to provide rich mixture. And for that, we are using choke. Third problem, during idling, we want rich mixture, but it is unable to supply rich mixture. And to overcome this problem, we have idling system. Okay, now these things we are going to again explain. Only now you will try to understand over here what is the problem and what is the solution for that. So the first problem of throttle supplying rich mixture due to carburetor supplying rich mixture when the throttle is open progressively is solved by using compensating system. First problem, first solution. Second problem, during cold starting, carburetor is unable to supply required rich mixture. Problem is solved by using choke. Third problem, during idling, it is required to supply rich mixture, but it is unable to supply and using idling system. I hope everybody understood the three limitations and the solutions of this particular three limitations in a simple carburetor. Okay, so with this, I think the time is up and we have to stop now. So now, if you are understood the limitations, you can, that means if you are not understood any part of this particular limitations, the last point, whatever we have discussed, you can ask the questions. If you are understood, you can mark your attendance in the chat box and you can leave. Others, you can remain present and ask your doubt. So I request everybody to ask the doubt related to whatever the content we have discussed today. We can continue to discuss. Others, you can mark your attendance. I am asking everybody. So I have observed that so many are not marking their attendance in the chat and they are leaving. So don't do that. Those who have any doubt can remain and ask your doubt. Anybody having any doubt? Any doubt in whatever we have discussed? Any doubt? Please ask your doubt if any.
No, sir.
No doubt. Okay. So those who don't have any doubt can mark their attendance in the chat box and can leave. I will be providing the PPT to you. Don't worry. Also, I will scan the notes and put it on the group, which I have not done, which I have promised in the last lecture, but till date
Sir.
I have not done. Ha, bro, bola. Akshay.
सर आपण ऐकलंय की कधी कधी कार्बोरेटर एअर पकडतो म्हणजे नक्की काय असतं किंवा त्यात
कार्बोरेटर एअर पकडतो. कार्बोरेटर एअर पकडत
हा.
नाही. बेसिकली फ्युएल सिस्टम असते ती एअर पकडते. Basically what happens is when fuel is flowing in a pipe, okay, if the air bubbles gets into the pipe, then due to that particular air bubble, fuel is unable to move forward, and this particular problem is what you are calling as air getting into the fuel system. एअर पकडते आपण ज्याला म्हणतो, दॅट इज इट. म्हणजे कुठल्याही फ्लुइडच असं नाही, कुठल्याही फ्लुइड एका पाईप मधनं जर सुरुवातीला तुम्ही नळ चालू केल्या, आपल्या पाण्याचा नळ असतो तो चालू केल्या गेल्या, तुम्हाला लक्षात असेल की सुरुवातीला हवा येते बघा, फक्त का ती हवा तिथं आतमध्ये आहे, आणि जोपर्यंत ती हवा निघून जात नाहीये तोपर्यंत फ्युएल पुढं मूव्ह होऊ शकत नाहीये. मग सुरुवातीला फक्त हवाही निघून जाते आणि नंतर मग पाणी यायला चालू होतं. बरोबर का? ती जी हवा आहे ते प्रेशर, इट फॉर्म्स अ बबल. ओके, इट इज गेटिंग एंट्रॅप्ड इन द लिक्विड ऑन फ्रॉम बोथ द साइड्स. नाउ व्हॉट हॅपन्स व्हेन द प्रेशर इन्क्रीजेस? आपण प्रेशर का वाढवला? फ्लुइड मूव्ह करण्यासाठी. बरोबर, एका बाजूला पंप लावला, आपण प्रेशर वाढवला. परंतु होतंय काय, आपण जसं प्रेशर वाढवू तसं तो एअरचा बबल आहे तो कॉम्प्रेस होतो, बिकॉज एअर इज कॉम्प्रेसेबल. परंतु फ्लुइड पुढे मूव्ह झालं का? नाही. का मूव्ह झालं नाही? द एनर्जी विच वॉज देअर which was supposed to be there to move the fluid is being consumed for compressing the air. मग आपण परत प्रेशर रिलीव्ह केलं, काय झालं? परत आणखी एअर त्याची ओरिजिनल डायमेन्शनला येणार, परत आणखी एनर्जी सप्लाय केली, परत आणखी कॉन्ट्रॅक्ट होणार, म्हणजे तो बबल आहे तो छोटा होणार. परंतु तो मूव्ह झाला का? नाही. मूव्ह होणं अपेक्षित, फ्लुइड मूव्ह होण्यासाठी आपण एनर्जी दिली, प्रेशर दिला, परंतु ती एनर्जी कुणी कंझ्युम केली? एअर बबलनं कंझ्युम केली. बरोबर आहे. सो दिस इज कॉल्ड ॲज एअर गेटिंग ट्रॅप्ड इन द फ्युएल सिस्टम, आणि त्याला आपण एअर पकडणे असं म्हणतो. वी आर गोइंग टू डिस्कस दिस. वी आर गोइंग टू डिस्कस अबाउट एअर ब्लीडिंग. मग आपण एअर कशी काढून टाकायची यातनं आपण ती पण डिस्कस करणार आहे पुढे. तर या प्रॉब्लेमला आपण एअर, I think okay, very good. Anybody else having any problem?
ओके सर, थँक्यू सर.
Okay, if you don't have any problem, you can mark your attendance and in the chat, and then you can leave. Any doubt remaining? Sambhaji Patil. Any doubt? Okay, so nobody having any doubt. Thank you. You can stop.